Alright guys, so a supertype contains all the common attributes. A subtype contains the specific attributes. Discriminator is an attribute that indicates the subtype. Exclusive subtype means that the supertype can take on precisely one subtype. And the supertype is, a note here, is the supertype is always above all of its subtypes in the diagram. An inclusive subtype is that one supertype can relate to one or more subtypes. I made a little error here, so I crossed this out. And inheritance is entities in the subtypes inherit the attributes of the supertype entity class. So you might not understand what I'm saying, but basically what these concepts mean. You have a supertype, let's say items. And this, remember, this isn't regular schema right now. This isn't the actual way you delineate it. It's sort of like it, but I'm just showing you, this is just a concept example. This is not original or crowsfoot notation. This is just my own delineation to you of what these concepts mean. Items, you could have a sword, a health pickup, let's just say, or a gun. No, let's say arrow, right? So we have an arrow, a health pickup, or a sword, right? So basically, the super type here would be the items. But now each of these would be a subtype. Now, an item could only be an arrow, health, or sword in any one instance. So this would be exclusive. So this is getting more towards the original, the crow's foot notation of it. But don't take this, word for word. You'd have to. I can show you later on the official notation. This is just to, again, get this concept across to you. Now, the discriminator would be like a Boolean, which would be like is sword, and this would be is health, and this would be, is arrow. And if you had two of these, you could just do one, which if it was false, it would be the other one. And so you have these are the discriminators, which indicate which one of these it is, right? Now, an inclusive subtype is where it can be two of these or more, right? But I put an X here because it's exclusive, meaning it could either, if you have a sword, it can't be a health pickup, right? And inheritance means that this item might have strength, or this item could have points, right? But then a health item would have health added. So you may have, this is like a really bad example that said points up here, but like this would have strength. So these are specific, right? Whereas items, belonging to a character, right? So each item can belong to a character, so like a belong property. Now each of these items can belong to a character. So each of these also has that belong property. We don't write that in here, but they have that belong property. Again, this isn't official notation anyway. But, the strength is particular to the sword. The health added is particular to the health. And the piercing damage is relatable to the arrow. But this belong attribute, okay, applies to all three of these. We're just not writing it in because it's implied because they inherit from items. So up here, this is what we meant when we said all the general stuff happens up here. All the specific stuff is written down here. So then you have a sword that, through inheritance, belongs to a character and has a certain strength. Okay, now moving on with that. Moving on. We're going to jump into now logical design. So we're actually leaving the stage of conceptual design and we're moving to logical design. And you'll see how this is different. So basically, an ER model doesn't take into consideration any database related concepts. And we have three aspects of a relational model, and this is where we're going to end off. So you can maybe think of what those three aspects are, and I'll see you in the next tutorial.